Hi, I'm Mike Fairborn, Chief Meteorologist here at WCCO TV. Nowadays, most of us live in cities where our contact with the soil is limited to walking or playing on it. But there's a quiet crisis in the soil. It's being depleted as farmers all over the world try to produce more and more food. So with the Minnesota Association of Soil and Water Conservation Districts, we've created a series of stories about the soil and its conservation. Soil is one of our most vital natural resources, but too often we take it for granted and treat it like dirt. Did you know that if you make a cut into the earth, you'll see different layers in the soil and that one of those layers is alive? Each spring, the land turns green, renewing itself in a cycle of birth, growth, and finally death. It's a miracle that takes place in the thin layer of soil that covers the continents of the earth. Soil is the sphere where life meets death and begins again.
The Indian people believe that the earth is alive. This is alive. This is living. Actually, Indians believe the stone here is alive also. But this is no question. You could actually scientifically prove that this is alive.
Hidden in each acre of soil are trillions, yes, trillions of tiny plants and animals that are an essential link in the chain of life. These microorganisms eat and decompose dead plants and animals. This frees up nutrients that can be used again.
We're going to talk about the soil profile today.
When you find a cut into the earth, you can easily see where the microorganisms are. Most are found in the surface layer called topsoil. It's usually darker in color because of the life and death process in it.
What we're talking about that lives in that topsoil?
Worms.
Earthworms are one of the most familiar members of the topsoil community. Millipedes and other insects are part of the family too. Below the topsoil, there's usually another layer, lighter in color, called subsoil. Larger animals like foxes or moles dig into the subsoil to make their dens. Below the subsoil, there's usually a layer of rock called parent material. These layers make a soil profile, and depending on the geology of the area you're in, a soil profile can look very different.
How much topsoil do you have there, Carol?
But whatever it looks like, the topsoil at the surface is the live zone, and all the food we eat grows there. We're part of the soil community too.
Topsoil?
It takes about 100 years to make about 1 inch of topsoil, the surface layer. That's why it's so precious, and the best farmland with a thick layer of topsoil can cost thousands of dollars an acre. So what are the 3 layers of a soil profile? They are topsoil, the live zone, subsoil, the transition zone between organic matter at the surface and the parent material underneath. When you look more closely at the soil, especially the surface layer, there are other things you start to notice. Farmers and gardeners know that the best soil for growing crops and vegetables has lots of biological activity in it, lots of microorganisms and earthworms. But some topsoils are more alive than others. What makes them different? It's the way the particles they're made of are combined.
Sort of dig around. We don't want to stab them. See if we can find any that are still around.
If you've ever dug for potatoes or made mud pies, you know it can be fun to touch the soil. And you know not all soil feels the same. Some soils are crumbly. Some make nice ribbons when you squeeze them. The difference depends on the size of their particles. Sand is the largest, followed by silt, and then clay.
When you have soil, the soil is composed of a mixture of these different things, sand, clay, and silt. You just necessarily won't have one soil that consists of one or the other. It's normally some kind of a mixture. Now, the state of Minnesota, for example, has over 3,000 different kinds of soil in it. Nationwide, in the United States, there's probably 70,000 different kinds of soil.
If you mix a typical Minnesota soil in water, each of the 3 particles will settle out by size. Sand on the bottom, silt above, and clay, the smallest, still in suspension.
In some places, it's darker because it has a little more loam to it. This is a little more sandy here in the garden.
The mix of soil particles determines how much water the soil will hold. Loam, the best soil for growing, has the right mixture of each of the basic building blocks.
Farmers use soil to help them determine what kind of crops they're going to grow. Construction people, they use soil as information to help them decide where to put bridges, culverts, drainage systems. Homeowners might use soil as information to help them decide where to build a house.
Knowing what's right under your feet could be a big help. If you don't analyze the soils around a building foundation properly, you could end up with a wet basement. Different soils, because of the combinations of their soil particles, have different properties and different uses. So checking a soil survey from your county is the first step in making the best use of whatever soil you care about. You remember the 3 types of soil particles? They are clay, which is the smallest, silt, the next smallest, and sand, which is the largest. People have been using the soil for farming about 10,000 years, and while farming formed the foundation of civilization, it's been practiced in a way that depletes the soil and makes it vulnerable to the elements of water and wind. Our next story looks at this process, how soil gets displaced or lost by erosion. Just a few seasons of storms can wash away the 6 to 8 inch layer of topsoil that covers an unprotected average field. To unlock the valuable nutrients stored in the topsoil, farmers have to dig into the earth and expose the soil. But big openings in the land make it vulnerable to erosion. Erosion by wind or water is the process which gradually carries away the layer of topsoil. Each year, about 5 billion tons of soil erodes in the United States. But during the 1930s, farmers developed conservation practices that reduced the problem of erosion.
What's happening?
It's all dripping. It's dripping down. It's eroding down into the bucket.
Bare fields are very vulnerable to erosion, but if the field has plant cover, the leaves slow the rain and the roots hold the soil in place.
Okay, here's another kind of plant cover, right? What is this?
Corn.
Corn after it's harvested.
On land with more slope, some farmers build the soil into a terrace that holds the rain so it will sink down into the soil and nourish the plants. Some terrace systems also have a grass waterway, so excess water has a place to run off without eroding topsoil.
Would it make a difference if we had our furrows this way?
Yeah, I think. Yeah.
Or if we had them this way?
That way.
Okay, this is contour farming.
Farming along the contour of the land produces rows perpendicular to the slope that will slow and hold the rain.
They're important because they protect this topsoil from water erosion when there's a rainstorm.
Soil erosion is a natural process, but human farming practices have speeded it up dramatically, faster than nature can adapt. So conservation farming practices are an important way to slow and even reverse this trend. What are farmers doing to prevent water erosion? Well, the answers for the worksheet are they terrace, they farm on the contour of the land, and they build a grass waterway to carry the water away, and grow or leave plant cover on their fields. The most serious form of erosion that affects Minnesota farmland is not from water, though. It's from wind blowing across the dry prairie land in the northwestern corner of the state. Each year, millions of tons of topsoil are just blown away.
For millions of acres of these sun-scorched, wind-eroded lands, we shall have on our hands a new man-made Sahara.
Dramatic images of wind erosion from the drought of the 1930s. But every year in Minnesota, the wind still wreaks havoc with our careless ways. In fact, wind displaced enough soil from Minnesota cropland in 1982 to fill 35 metrodomes.
What's happening to your soil?
The wind's blowing it off.
Yes.
And she ain't gonna have no soil no more.
That's right. We're going to do it.
As each particle of soil crashes into its neighbors, several more particles break loose. When the fields are bare, especially each winter, more and more soil particles erode. It's snert, snow and dirt together. Fall plowing, particularly in the western part of the state where there's less snowfall, makes topsoil extremely vulnerable to winter winds. But if last year's crop residue stays on the field, the plant cover slows down the wind and erosion damage is less.
This field has a strip of row crop this way, and a strip of plant cover, and a strip of row crop. This is called contour strip cropping.
Planting crops in strips reduces wind erosion by breaking up long expanses of bare soil. Trees planted in rows along a field as windbreaks can also slow the winds. The more plant cover of all shapes and sizes, the better.
Let's take a look at this field that has plant cover, and let's see what happened when there's wind erosion. What's happening to the soil?
In 1935, Congress created the Soil Conservation Service to provide farmers with information about how to prevent wind and water erosion. You can see evidence of its work in a farm field with leftover corn stalks, or in the fact that Minnesotans planted more than 600 miles of windbreaks last year, more than any other state. Can you name 3 things farmers can do to prevent wind erosion? They can plant windbreaks of trees or crops, leave plant cover on their fields, and plant in alternating rows, strip cropping. Not all soil erosion takes place on farms. It takes place wherever the soil is exposed. And in our cities and towns, large amounts of soil are exposed under construction. Construction workers in our towns and cities push lots of soil around to make way for highways and homes. The large area of exposed soil on building sites means water and wind can cause trouble. So it's no surprise that soil erosion per acre is greater on a construction site than on a farm. Building crews have a big job preventing erosion. And road crews use one of the same techniques as farmers, plant cover. Freeway interchanges, for instance, are seeded with grass, then a mulch of hay or straw is spread over the seed to control erosion until the grass grows. In a few weeks, the grass is established and holds the soil on the steep banks. Sometimes a strong barrier is needed to control erosion on a work site. It's called a silt fence.
What that does, it stops all the sedimentation from running down into places like this pond behind us.
Sometimes construction crews build ponds themselves, ponds that catch runoff before it reaches a larger body of water. These catchment ponds are becoming more common in housing developments as we try to prevent soil erosion from degrading our lakes and rivers.
I know some people ask me what I do, for a living, and instead of saying I do erosion control, I say I help protect nature.
In fact, some 60% of the sediment reaching streams is from non-farm causes. A lot of the problems our city lakes are having, milfoil, rough fish, are made worse because of the soil erosion. So some cities and counties have passed laws to require erosion control on construction sites. What are some of the ways that construction crews prevent erosion? Well, they plant grass seed and they cover with a mulch of straw. They construct a silt fence or build a catchment pond to slow running water. So far, we've learned how soil, one of our most valuable natural resources, is disappearing. Remember, it takes 100 years to make 1 inch of topsoil. So soil erosion is a crisis, a quiet crisis for the long-term health of our food-producing land. It's a noisier crisis for the lakes and rivers where eroded soil goes. Runoff from our farms and cities is degrading their water quality and threatening to fill them up with sediment.
There's places where it was like 8 feet deep only out here. Need at least 9 feet for the barges, so we're going to dig it to 12 feet so we can haul for a little bit.
All summer long, the Army Corps of Engineers digs eroded soil out of the Mississippi River, more than 1 million tons each season in the St. Paul district alone. Besides filling our river channels, eroded soil carries extra nutrients from our fields and lawns into the lakes and rivers. These nutrients make the lake's plants grow faster, and the lake's aging process speeds up. If we don't stop erosion as we open more and more land for farms and cities, our lakes will gradually get shallower and warmer and won't support the same variety of plants and animals.
We're planting some rainbow trout
Lac Lavon, an old gravel pit in Apple Valley, is a case in point. It's a cold, clear lake just right for trout. But as home building continues around the lake, runoff from the steep embankments and storm sewers is putting extra nutrients into the lake.
This lake could be, destroyed in terms of its value as a fisheries management lake, but I don't think that'll happen unless, the area is neglected.
Homeowners around the lake have organized themselves to take care of this resource. They have a newsletter and share ideas about the best ways to keep eroded soil and excess nutrients out of the lake. When soil erodes, even more than our lakes and cropland suffer. Other natural balances are upset. Animal and plant habitat changes. Fewer game fish thrive. The biological diversity of the environment also suffers.
This one is usually a 2-year job. Every 2 years it's built out far enough that we're going to have to dig it again in 2 years.
In the 1930s, sediment in the Mississippi River slowed barge traffic to a crawl, a fact that led to the creation of the Soil Conservation Service. Today, erosion still costs farmers billions of dollars each year in lost soil fertility, and we all pay for dredging and degraded water quality. So, what happens to a lake or river filling with eroded soil? Well, the answers to the worksheet question are it gets shallower and warmer and can support fewer game fish. Soil erosion is a problem in every region of the state. But how can we prevent it when the geography of the state varies and each square mile of the soil is so different? Well, one of the best ways is keeping the land in small enough units, the family farm. In Goodhue County, the Reese family has been farming the same land almost 100 years.
Our farm is 200 acres, and because we're dairy, the main thing that we raise is the feed for the cattle, which would be mainly hay and corn.
I use mulch tillage, chisel plow and cultivator rather than moldboard plow and disc. Tends to leave the crop residue on top so that it breaks up the raindrops when they fall and tends to soak it up better. Well, the whole farm is in strips on the contour or around the hills. While working around the hills, you're making ridges basically on the level that help to hold the rain when it falls. Back when people farmed up and down the hills, or our farm anyway, the topsoil was leaving and the crops were getting poorer. And keeping the soil where it belongs, you're gradually improving the soil rather than letting the topsoil run down into the streams and lakes.
Oh, look, Paul. It's a good feeling to know in the morning after the storm is over with that our soil is still here and it isn't ending up in the Mississippi River. I guess Paul is the one that has a bigger inclination toward the farm. And, I'm sure that he wants to do like his dad has done.
I hope they're learning some things about soil stewardship and care of the soil. Whether they want to farm or not, that's something they have to make up their own minds about.
The closer a person is to the soil, the more you realize that it's your responsibility to take care of the soil. We're only here for maybe 40, 50, maybe 60 years living on the farm, but there are hopefully many generations after us, and we'd like that soil to be in good shape for them too.
The Reese family also rotates the crops on its contour strips every 4 years, enriching the soil with alfalfa before it produces another year of field corn. Can you name the farming practices the Reese family uses to prevent erosion and improve the soil? Those practices are contour strip cropping, crop rotation, and leaving plant residue on the field till the next season. Our next story looks at values, the values we share as members of an ecological community. It's a community that includes soils, waters, plants, and animals all together, the land. The value system is a conservation ethic, and Minnesota's first farmers, the Sioux and Ojibwe people, have practiced it for thousands of years.
Inamaka, Mother Earth, Awayanke, we shall protect you. So,
nature always spoke to them, always spoke to them. Then down through time, agriculture was their existence.
In fact, many of our most familiar foods, potatoes, corn, squash, beans, and tomatoes, are plants cultivated by Indian peoples. And the ceremonies that were part of planting and harvesting grew from the special appreciation Native peoples have for the earth, their conservation ethic.
Come up.
The early European farmers in America borrowed knowledge and values from the Indians, but used domesticated animals to work the fields. When farming for food changed to farming for market during the last century, what was left of the Indian conservation ethic was swept aside. Today's mechanized, oil-intensive farming has allowed most of us to leave the land for life in cities, but we've also lost its softening touch. Despite, or maybe because of, our distance from the soil, the problems of industrial farming are at our doorsteps. Pesticides in our food, fertilizers in our water, eroding soil in our lakes and rivers.
We know that a lot of the topsoil on this farm, about half of it's been lost, and we just can't afford to lose any more.
Ridge Lake Farm in Swift County is one place where a conservation ethic is returning. The soil, the water, and the forest are getting equal attention.
Anytime you approach a farm or any other piece of land, of course, you're looking for the best use of that land. In this case, using this as a marsh is the best use of that land. It's really too wet for good pasture.
So Bill Omicon and his partners built a stone dam on the stream that runs through the farm.
On the other hand, over that way we've got loamy sand that we're going more to trees as both a wildlife measure and as an income crop.
Other farmers are practicing a conservation ethic too, growing wheat and soybeans in the same field, plowing or tilling on a narrow ridge, rotating a soybean crop into last year's corn stubble. Farmers are even getting conservation ideas from computers. They can look at farm landscapes that show a variety of ways to farm and care for the land before they start the tractor.
Land should be used for its best purpose. Land's the basis of our whole country. If we don't have good land, we're no better off than the people that have to live on top of a mountain.
Or a desert. In fact, much of what is now desert in the Middle East, for instance, is the result of overusing the land. Aldo Leopold, the Wisconsin naturalist, said it this way: "We abuse the land because we regard it as something that we own. When we see the land as a community to which we belong, we begin to use it with love and respect." The worksheet assignment for this story is to name the members of the soil community, the parts of a conservation ethic. They are the soil, the water, the forests, and probably the most important, people. So far, we've seen how farmers and construction workers can keep topsoil from eroding, but what can the rest of us do to practice a conservation ethic on a smaller scale, in our own yards? How can we keep the soil where it is? The joy of planting is an ancient one. Agriculture is about 10,000 years old. But planting on a slope, whether it's corn in the field or hostas in the yard, makes the soil vulnerable to erosion.
And what you want to do is minimize that runoff. And you might do that by a retaining wall that brings point A and B together, by terracing that, or by filling that slope up with enough plant materials that slows the water flow.
But not everybody thinks about that. And soil nutrients and chemicals that run off from our lawns and gardens are trouble in our lakes. What can we do to keep the topsoil in our landscapes? Besides building terraces or retaining walls, adding mulch, dead plant material spread on the ground, keeps soil in place.
One of the mulches we like a lot is a shredded bark mulch because it interweaves and you can put it on a really steep hill and even in a really heavy rainstorm it'll keep the soil from washing down.
Living plants are another way to keep it there.
Now, one of the really popular ones for sun, of course, is these days is the native prairie plants, which have extremely deep roots and can grow in even terrible soil like this, and also do really well in droughty years.
But are prairie grasses neat enough for a city yard? At a university computer, researchers are experimenting with the way we see the landscape.
We're trying to take some of the things that we've learned from farmers and rural people about what makes landscapes look attractive, makes them look neat and tidy, and at the same time incorporates biological diversity.
Diversity means having a variety of plants in the yard, less lawn that needs watering and mowing.
There's a greater diversity of heights of plant materials. There are very tall trees. There are shrubs that can act as cover for wildlife. So what that means is we have to change the way we look at things.
Finally, another good mulch is compost, decayed plant material. It covers the soil to protect it and adds nutrients that build up the topsoil layer, just like nature has for centuries in the forests and prairies. We can imitate the forest in our own yards by leaving fallen leaves around our landscape plants each fall. The soil and the plants will be more protected all winter, nourished come spring, and less likely to dry out during summer. What are some other things we can do to practice conservation in our own yards? We can mulch, we can add plants and trees to the landscape, and we can start a compost pile to recycle nutrients back to the soil. With the final story of Soil Forever, we return to the subject of the first story, Live Zone. Remember those microorganisms in the topsoil? They're the key to doing more in our yards than preventing soil erosion. Those microbes can help us improve the soil by composting, recycling our yard waste and kitchen scraps. As you watch, keep track of what you need to make compost.
Everything that I used to throw away, I now incorporate into the soil.
In the process of nature, there is no throw it away. Everything is used again, recycled. That's the basic principle of composting, the process of decay.
When I'm composting, what I'm doing is what Mother Nature does all the time, except I'm hurrying up the process.
But you don't have to be in a hurry to compost. It's the microorganisms in the soil that do all the work. You just have to provide the ingredients.
The first layer that's necessary is plant material of some sort. That can be leaves, grass, kitchen scraps. Second thing I need is soil, garden soil or ready-made compost.
Then make sure everything is moist so the microorganisms have enough to drink.
Doesn't it stink? The answer to that is if the pile is turned regularly and it's aerated, no. A good, healthy compost pile will smell good.
Depending on its ingredients, how warm the weather is, and how often you turn the pile, the compost will be ready in a couple of weeks or a couple of years. Enclosures for compost come in different shapes and sizes, from a simple wire fence to a 3-bin wooden box system to a county facility 4 acres in size.
We're losing roughly 100 million tons of topsoil every year to wind and water erosion. And what we do with the plant matter, the vegetable matter here, is we turn it into a material that's very close to topsoil.
Whether you get it from the county or make it yourself, compost gives topsoil the nourishment it needs to stay healthy.
You know, suppose that all works its way back and you're nurturing the soil, you're taking the food from it and you're giving it something back.
We depend on the soil for our food. We're part of the soil community. But with more mouths to feed than ever before, the soil is wearing thin. So creating it by composting and conserving what we've got are the best ways to make sure we can meet our food needs. Do you remember what you need to make compost? The answers for the worksheet are: you need leaves and grass, food scraps but no animal products, a little water, air from turning it, and microorganisms from the soil. One final thought about soil conservation. We do not inherit the land from our parents. We borrow it from our children. If you have questions about soil conservation, contact the Soil and Water Conservation District office in your county. The people there and at the College of Soil Sciences at the U of M helped us with the questions we had. Thanks to all of them. I'm Mike Fairborn from Weather Center 4.